Okay, good evening everyone. This is in continuation to our lesson about convolutional neural network. This time we are going to compute the total number of rows and columns in the next layer. So in this example, the input layer contains 39 by 39 by 3 matrix. So our number of height and width is equals to 39 and number of channels is equals to 3. So our filter F1 is equals to 3, the stride is equals to 1, the padding is equals to 0, and the number of filters is equals to 10. So Rn, using the formula, Rn is equals to 39. Okay, and then F is equals to 3, S is equals to 1, and P is equals to 0. So our formula, N, here, this formula. So N, so 39 plus 0 minus 3. Why 0? Because our P is equals to 0. Divided by 1, which is the S plus 1. So you have 36 plus 1, which is equals to 37. So that's why the first value is 37. The same is true with the second value for the columns, which is 37. And the filters is equals to 10. Now next is that from the first layer to the second layer. So remember the formula, N plus 2P minus F divided by S plus 1. So what is given here? 37, our F is equals to 5, our stride is equals to 2, and P is equals to 0. So N again is you have 37, our P is equals to 0, so that is plus 0, our F is equals to 5, divided by S2 is equals to 2. So 37 minus 5 is equals to 32 divided by 2, which is equals to 16 plus 1, which is equals to 17. So this is now the value for the second layer, 17 plus by 17 by 20. And lastly, on the third layer, we need to remember again the formula, N plus 2P minus F divided by S plus 1. So our N here, our N is equals to 17, our F is equals to 5, our S is equals to 2, and P is equals to 0. So N, so you have the formula 17 plus 0 minus 5 divided by S is 2. So that is 12 divided by 2 plus 1, and that is 6 plus 1, which is equals to 7. So the last or the third layer has the matrix 7 by 7 by 40. Okay, so that's about the computation. Now, when we talk about the types of layer of CNN, so when you implement CNN, you have to take note, number 1, with the convolutional layer, with a pooling layer, wherein pooling layers are generally used to reduce the size of the inputs. So in this example, we have a 4 by 4 input, and then we use the max pooling, so meaning on the green area matrix, the maximum value is 9. So you have 9. On the red area, the maximum value is 2. On the purple area, the maximum value is 6, and on the light blue area, you have the maximum value of 3. So that's the implementation of pooling layer. And of course, don't forget to use the fully connected layer, wherein you flatten the high-level features that are learned by convolutional layers and combining all the features. Now, in the implementation in Python, what are those operations? You have to identify the feature detector or the filter. So we call that feature detector as the kernel. And then feature detector detects features like edges or convex shapes. And of course, you have to map the input image into the feature detector element-wise. So it's the same implementation with how you compute here using convolutional. So it's element wise. So this is the original multiplied by the filter. Next is feature map. You also have a convol feature, and of course you have to identify the stride. Now it's possible that when you create the model, so this is an example of a fully connected layer, but given the fully connected layer, you can implement a dropout. We were in a technique, it randomly selected neurons that are ignored during training. So in the Python implementation, your data set is the digit recognizer. It composes of two data sets, the CNN train CSV and CNN test CSV. So how would you load? So use the pandas and then take a peek. So in this example, there are around 42,000 rows and 785 columns. So you have the label and the pixels, combination of pixels. Same is true with your test data set. The test data set is composed of 28,000 rows and 784 columns. Now we need to identify the labels for our train data. So train here, we have label, and then we need to drop the label for our X train data. So it's important that you do normalization. Same is true when you do the basic machine learning algorithm. You need to perform normalization. You need to reshape the value. And of course, you need to perform label encoding. So, so this is an example of normalization in an image. You divide because the maximum value is 255. So we have this train shape and test shape. Then you need to reshape your data so that it is going to feed an entire image into different rows. You also need to perform label encoding for the values wherein the number of classes is 10. Now don't forget the train, test, and split the data. Okay? So what happens here is that the train, so we have the X train and then the Y train. The test size is 0.1 and the random state is 2. So when you do modeling, you need to again use the sequential method, the dense method, and the dropout, and also flatten. And for the convolutional neural network, you have convolutional 2D and the max pooling 2D. We'll be using Adam for the optimizer. So when you create, so start with instantiating your sequential model. Then add the input layer. So we have convolutional 2D. So we have the number of filters and the kernel size. So you have the filter, and then padding is the same. So the activation, don't forget the activation, which is equals to ReLU. So we'll be using the max pooling, wherein the pool size is 2 by 2. And then drop randomly some variables. We also have here, for the hidden layer, perform again a convolutional neural network, 2D. And then the filter size, we increase the filter size. into you increase the filter size at 216 and then the kernel size into 3. So the max pooling of 2 by 2 and then the strides. And then lastly, you need to flatten and then feed it up to 256 neurons and your activation is ReLU and then perform 50% dropout and then detect those 10 different values for multi-classification and the activation is softmax. So this is how you display the summary of your model. So after you create your model, you need to compile. We use the Adam optimizer and then call the compile function. Since we perform multi-classification, your loss function is categorical cross entropy and you have to use the matrix accuracy. Now, since we're doing an image classification, our data may not be enough, so we need to perform some image augmentation. So in this example, we have to use the image data generator in order to create an image augmentation. So this is the flow for the image augmentation. So what is true here is the rotation, the range, the shape of the width, the height only. So a little tweak on our data. And then of course you need to fit your trained data. So fit the augmented data to the model. Since we use data generation generator, so we have to use datagen.flow that is from X train and Y train. And then our validation data, so you have to use the xval and the yval, and the steps per epoch, you have to use the shape sub-0 divided by the batch size. So you have this monitoring of your accuracy and loss. So when we plot, okay, the accuracy and the loss, so when we try to look at the sample output, your test data accuracy is higher than the trained data. This is good because they try to fit accordingly. So with also the loss, your test data and the trained data, which seems to go in parallel. So we can say that our model is good for our training data set. So we have here a sample prediction using the confusion matrix. Thank you.